again, you haven't noticed the theme for this this course. A good majority of the theme for this course is graphing. So we're going to continue to do the graphing that we have been doing all along. We'll be continuing to use the same rules that we've been using all along. Now we're just adding on to a little bit of it. Okay, this isn't a very difficult section, but it's a section that you are able to do. Rational functions. Rational functions are functions in which you have they use y equals p of x over q of x, where p of x and q of x are polynomial expressions. And q of x, in this case j of x, can't equal 0. So I'll just change that. So that's p of x over q of x. Okay. Now, this actually goes back to one of the 5 graphs that we have talked about, all right, since grade 11. One of the ones that we want to know. And that starts with this guy right here. F of x is equal to 1 over x. Okay, so this is the graph. This will be our initial graph, our starting point graph. And then what are we going to do with it? Well, what do we know about this graph? What does it look like? Can we remember what that graph looks like? It's one of the 5 that we're supposed to know. Yeah, but across from each other. Okay? So it looks like this. Crosses through that coordinate there. And this coordinate right here. What are those 2 coordinates? What's this coordinate? 1 and 1. And this one? -1, -1. And we should add in this here. Okay, there's our asymptotes. All right, so that is one of those graphs. So now what we're going to look at is what happens when how do we change the graph? Okay, the one good thing about this graph is we don't use the b function or the b operation in it, meaning we don't need to shrink the horizontal or shrink the x values in this graph. Okay, actually I shouldn't say that. There is a point where you that you may see a value in which you have to factor out, but right now they're not going to use it. So the standard equation for this graph is this: a x minus h add k. And all 3 of those variables all mean the exact same thing that they meant since day 1. A changes your y values, you multiply your y values. H does what? Left or right, and K moves it up or down. So our goal today is just to get it into this form of that. Okay, so that we have it in this is what they call the quotient remainder form. Okay? Again, this is one where we have to do non-permissible values. So let's look at an example. We've got y equals so in words, what are we doing to this graph? What are we doing to the 1 over x graph? Okay. So whispering. What are we doing? Multiply all the y values by 3. Left 4, up 5. Okay, perfect. Okay, so the first thing you do is you do your stretch first. So the cheating way of doing it, but still right, is that. So I don't even have to move the graph. Okay? That's the easiest way to do that. All right? Now, remember again, I have my asymptotes. So I'm going to move my asymptotes first, and then I'll place it. Or it doesn't matter, I guess. So which way did you say this coordinate has to go? Left 4. So over to here. 1, 2, 3, right there. Yeah, and then up 5. 1, 2, 3, 4, 5. So this isn't very good here. How can I do this? I'll have to move this down a bit.
Can't you, like, double click it? No, just just right in the middle of it. Yeah, there you go.
So, let's just do this. Okay, start it again. Alright, so I've got this down here. So we started 1 and 3 right here, right? We're gonna move it 1, 2, 3, 4 here, up 5, 1, 2, 3, 4, 5. So that is going to move that's that coordinate. Okay, 0, 0 is gonna go there and up 5. To there. So here, like that, and then that other coordinate will be right here, there, and there. Okay, so again, the difference between the applied course and the pre-calculus course is we're supposed to do more of these by hand without the use of the calculator. Okay? So this one's easy because it's in our form. We know how to do it. We got an A, we got an H, we got a K, and we just move it according, right? So what happens if we have this though? 6 over x minus 4. Okay? So what's the difference between that graph and the last graph that we worked with? There's an x on the top, right? So there's a problem with that. For us, it makes it a little more difficult to graph, correct? Okay, so here's what we're going to do then. This is a brand new process to you. We haven't done this before, but it's very similar to completing the square. Because basically what I'm going to do is I'm going to add and I'm going to subtract the exact same value so it doesn't change it. And then I'll use brackets to simplify it for myself. Does everybody understand what I'm saying? Okay, so here's how it looks. I'm going to take a value, and the value in here is going to be what I want to do. Okay, so I'm going to. So at this point, don't write this down yet. The value I chose right here was the value that I would have to factor out away from this number to get what I got on the bottom here. So my objective here is I'm going to take this value times that value. Can you guys get your crap together? So I'm taking 3 times 4, negative 4, and I'm going to subtract 12. Now I'm going to, because I subtracted 12 here, I'm going to add 12 here as well. Add 6. And all of that is over x minus 4. Okay, so far? So now, what I'm going to do is I have brackets around here and brackets around here. I'm going to separate them so that they're both over x minus 4. So this one's going to become 3 x minus 4 over x minus 4 plus 12 and 6 make 18 over x minus 4. So I separated these two values, these two terms here, and put them over x minus 4 and x minus 4. You follow so far? Okay, so I'll come back to it and explain it in a second. So then that cancels and that cancels. So it leaves me with 18 over x minus 4 plus 3. What's my a value? 18. What's my h value? 4. And my k value? Okay? So this is just a neat little trick that allows us to get it into the form so that we have to just use our transformations at that point. Okay, let's go to page 300. So we're going to take this. Page 300 is going to incorporate everything. So I want you to follow through in your book. So write this down as we go through it. Okay, so we're going to start this time. Y equals 4x plus 2, correct? Over x minus 1. Okay? So, again, when we do the sketches, we want x-intercepts, we want y-intercepts, we want those key values. So for this one, there's only the two key values outside of the intercepts. That's plus, where you have the ones in the, what do we call that? When we have 1 and 1 and minus 1 and minus 1. Remember where they don't change? Invariant points. Very good. Okay, well done. Invariant points. Okay, so the invariant points, the intercepts, and then your asymptotes. Those are the things that we need for these graphs, these rational function graphs. Okay? So, first thing we'll do is let's find the y-intercept. So y-intercept is equal to okay, put x equaling 0. So what does it equal? Minus 2. Right? Okay, so far, any questions? So there's where it's going to cross the y-axis. Let's find out where it's going to cross the x-axis. So what do I do now? Go ahead. X minus 1?
Yeah. You said plus. So x minus.
Yeah. So multiply that up to here. What do I get? 0. 0 equals 4x add 2. X is equal to minus a half. So I have my two intercepts now. Okay, so my y-intercept coordinate, 0, negative 2, minus 1/2, and 0. So far, so good. Now I want to put it into the correct form so that I can graph it. So I have to add and subtract something to it. So what is it that I want to add and subtract to? So I've got 4x here. What am I going to add or subtract to it? Subtract 4. Add 4. Add 2. Okay? Carlton, how come you use negative 4 there?
Times 4x times -1.
Yeah. You took this coefficient and multiplied it by that number right there. That constant. Okay? So now, factor it out. And split up my fractions. What's my A value? 6. What's my H value? 1. And what's my K value? 4. Okay. So my first coordinate right here is 1 and 6. Right? My coordinate right here is -1 and -6. Okay? And where am I going to move them to? Right 1, up 4. Right 1, up 4. So that point goes right there. Okay? My 0 and 0 goes right 1, up 4. Okay? This one goes right 1, up 4. Oops. We're at -6 right now, right? Shoot. Okay, my bad. Let me do this again. Well, just. Oops. Because I need to make this look right. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, so -1 and -6. 1, 2, 3, 4, 5, -6 is right here. So that's -1, -6. 1 and 6 is 1, 2, 3, 4, 5, 6 right there. So I'm going to move it over 1 here and then up to 10. So that goes right there. So that value then becomes 1 and 10. Agreed? This guy's going to go over 1 and up to here. So that's
Wouldn't it be 2 and 10?
2 and 10. Right, thank you. 2 and 10. And then this one's going to be right 1 up to -2, correct? It's right here. So that would be 0, -2. Agreed? My 0 and 0 comes over 1 and then up 4 to 1 and 4. So it's right here, right? There's 1. And what do we have to make sure right here? Is it's got to go through -0.5 and 0. So it's got to go that and that. So my intercepts are right there. This also happens to be one of my invariant points that we started with. And there's my invariant point there. Okay? So going back through this, y-intercept found it first. X-intercept found it second. Change the equation so that it's set up for y is equal to. Don't do what I did. Use half a mark. Make sure your final equations always have y equals in them. Don't lose those. All right? Any questions? This actually is a shorter section. So 9, 1, 9, 2. 3. Friday. Yeah, our goal will be to test by Tuesday. So I will do. Let me introduce 9.2 right now. Okay, as long as there's no other questions. Are there any questions about? Oops. Oh, I didn't want that either. No. Are there any other questions about that 9.1? Go ahead. No? Wait. Okay. All right, now. Actually, take